Okay, so we'll be doing problem 10. To go from f double prime to f prime, you'll see that on the left of 0, that f double prime is above the x-axis, which means that f prime will be increasing because the slope is always positive. On the far left, the y values of f double prime start at 0, so the slope of f prime will be close to 0. On f double prime, we see that the y values quickly increase and increase towards infinity as the graph approaches x equals 0. So for f prime, the slope will go from values close to 0 and approach infinity, meaning the slope will be undefined at x equals 0. On the right side, we see that f double prime is below the x-axis, so f prime will be decreasing because it will have a negative slope. The y values of f double prime start from really large negative values and go towards 0 as we move along the graph. Because f double prime is a graph of the slope of f prime, the slope of f prime will be really negative near x equals 0, and the slope would go towards 0. To go from f prime to f, as you can see from f prime, the graph is always above the x-axis, so the graph of f is always increasing. From f double prime, you can see that since negative infinity to 0 is positive, the graph of f from negative infinity to 0 must be concave up. From 0 to positive infinity, the graph of f double prime is negative, so the graph of f from 0 to positive infinity will be concave down. And since 0 is undefined, we know that x equals 0 on the graph of f, there will be a vertical tangent line. There's no asymptote at x equals 0 since the problem states that the function is always rising. Therefore, the graph will curve like this. And we'll have a vertical tangent line here.